Hello, Eugene here. Today we're going to use the MLX90614. It's a infrared radiation remote temperature sensor. And what it is it's a GY906 sensor that's actually connected to a board that's actually called the MLX90614. So we're going to use wxWidgets. So this is in C++. And wxWidgets provides the GUI or the graphics of the program. And we're going to use I2C communication on a Raspberry Pi 4 on my CrowPi 2. And so what it's going to do is it's going to measure the infrared radiation. So there's radiation always around us, and one of the ways that heat gives off its temperature, or you can measure the temperature, is by the radiation of the heat that comes off you. So right now I'm producing heat at, what is it, 98.6 Fahrenheit. So I'm giving off radiation for that heat. Uh, this temperature sensor is good to about minus 40 Celsius, about minus 40 Fahrenheit, so they're the same number. And it goes up to about 125 Celsius or 260 degrees Fahrenheit. So why would you want to use this type of a temperature sensor? So if you have like a chemical reaction that you don't want to have any interference with, this is a great way to make it so that you can get the remote temperature of the material or whatever it is that you have without having any interference with some kind of a swizzle or the metal that's actually physically in contact with it. And it's got really high accuracy. It's good to about 0.1 degrees. Now it has a field of vision, which the field of vision is how wide the area is that it's going to be reading. And it's about 90 degrees. So you have to get this sensor fairly close to whatever the material is, so that way you can read it properly. So that's what we're going to be doing today. So here we have the CrowPi 2 with a bunch of the material on it and sensors. But what we're really looking at here is the MLX90614 with the sensor on top. And we have a 3.3 volt to power. The green is for ground. And then we have the SDA and SCL, so the clock and the data wiring on here. So it's hooked up to I2C, and here we have the C++ program. That's going to be on the link below to my GitHub. And I'm going to move this out of the way. And there we go. Then on here, what I'm going to show you here first, we end up compiling the C++ program. So we get G+, this is revision number 9. So I've had 9 different revisions of this. I hit the enter key. So what it's doing now is it's compiling. It's got the wxWidgets configuration, so it's got their libraries, it's got the flags, it's got I2C, and it's using the LGPIOD electronic library, which is the newest library for the Raspberry Pi. Then now that it's compiled, it's created a file called MLX90614 without the CPP, so it's a binary. And to run it, we run ./MLX90614-rev9, hit enter. Now we end up with the initial startup. So the initial startup shows that it's initialized successfully. We are running on I2C1, and the address for this component is 5/8, so that's hexadecimal. Then to get the temperature, you push the button. So there's 2 different temperatures. There's the object temperature, which is if I put my hand over top of it and do it, my hand will then be the object, which is at 23.11 Celsius. And I had that conversion here to Fahrenheit. But then it also has the ambient temperature, which is the surrounding area temperature, which is at 19.99 Celsius, which is about right for this room. It also has an emissivity value, and what that is if you're trying to get the temperature of something like a mirror, then that's going to be a different type of emissivity than for something like a hand, which easily absorbs or emits infrared radiation as in the form of heat. So that's what this program does. And then when we end up exiting here, it then shows that the connection was closed successfully. So this is how we use the CrowPi. We just use the I2C communication protocol, the MLX90614, and we get a distant temperature reading accurate to about 0.1 degrees. That's it. Thanks for tuning in, folks.